Welcome back. In this video, we're going to be working on section 6.2, which focuses on exponent rules. Specifically with multiplication. There's a couple of 3-4 different properties that we're going to learn about exponents. We're going to start with just basics of remembering what an exponent means, and then we'll look at the property that governs what happens when you multiply together two numbers raised to two different powers. So taking a look, when we write down the expression 3 squared equals 9, the 3 is called the base, the 2 is the exponent, and then the 9 is just the value of that expression. So the base is something that is being multiplied together. The exponent tells you how many of that base are multiplied together. And so we get 9 here. Make sure that you're getting 9 for this and not 6. We're not multiplying 3 times 2. We're multiplying 3 times 3 2 times. So that's how that goes. Try a few more. 4 raised to the third power, that we're multiplying 4 times itself 3 times. That gives us 64. 7 raised to the first power will give us 7. 5/6 squared is 5/6 times 5/6, and that's 25/36. Have to be careful when you're working with negative signs. -5 squared is the same as -5 times -5, and that's positive 25. For the last one, people always want to say that that's 25 also, but keep in mind the order of operations has us do powers first. So when you see negative of 5 squared, that's the negative of 5 times 5, or negative 25. It's not positive 25 because the 5 is getting squared before we're taking the opposite of, so you get negative 25. Okay, the terminology for raising numbers or doing this is called raising a number to a power. We say 3 to the second power in that first case. You will also hear people say things like 3 squared, which means the same thing as 3 to the second power. And it comes from how we find the area of a square that has a side of length 3, right? You'd multiply the height times the width to find that area is 9. That's why you say 3 squared, even if you're not actually working on a square. And similarly, if you had 5 raised to the third power, you may hear people refer to that as 5 cubed. And that's a similar reason. That's how you find a volume of a cube whose side lengths are all 5s. The formula for the volume of a cube is length times width times height. So for this cube, it will be 5 times 5 times 5, or 125, which is exactly what 5 to the third power is. That's the reason why we say cubed and squared. It's just shorter than saying to the second power and to the third power all the time. Okay, so that's been a quick look at just some exponents. We're going to look next to the product property for exponents. So that reads as follows. Here we have a raised to the m power times a raised to the n power. That will give you the same thing as a raised to the m plus n power. In other words, if you're multiplying two of the same base together raised to different powers, then it's sufficient to just add exponents. So let's try an example that illustrates why that may be so. If you had 2 cubed, and you were going to multiply that times 2 to the 5th power, and we were going to do this the long way. Well, the first one means we're multiplying together 3 2s. The second one means we're multiplying together 5 2s. How many 2s do I have altogether? 3 from the first one and 5 from the second one. 3 plus 2 is 8. That'll be 3 plus 5 is 8. That'll be the same as 2 to the 8th power. So this illustrates how you keep the same base and add the exponents. Okay, let's try this a few times. Remember that 5 by itself is the same as 5 to the first power. This would give us 5 to the 5th power, 1 plus 4 being 5. Here, 4 to the 7th power times 4 to the 7th power will be 4 to the 7 plus 7, or 14th power. X to the 27 plus 13th power, that's x to the 40th. Okay, in the next one, we have 3 factors, x raised to the 6th power, then 4, then 8. With a little thought, we should be able to realize that, well, if you actually saw me write out all those x's the way I did these 2's a minute ago, I'm not going to do it, don't worry. But if I did, I'd have to write out 6 x's, then 4 more x's, then 8 more x's on top of that, and that's a lot of x's. That's going to be 18 of those x's. So it's x to the 18th power. P to the 5th power times p is p to the 6th power. A squared times a cubed, that's a to the 5th power. B to the 5th power times b 7th power is b to the 12th power. And you'll notice here that we'll stop right there on this one. I can't combine it and say it's ab to the 17th or anything like that, because the rule that we're following, the base is the same. It's just a on both of those, okay? So it's here there's 2 different bases, a and b, so I can't just add exponents in that case. Okay, so that has been our first real property of exponents, the product property for exponents. Okay. The next one we'll have is the power property for exponents. And this one governs what happens if you raise a power up to a power. So here we have a raised to the m power, and then that all is raised to the n power. You can achieve the same result by raising a to the product of the 2 exponents. So let's try it. So if we had x squared cubed, this means that we'd have x squared times itself 3 times, right? X squared is being cubed. So each of these would give us 2 x's. Don't worry, I'll only do this once. That would be 6 of those x's, right? So that's x to the 6th power. Multiply the exponents together. Okay, let's try this. If we had y squared raised to the 5th power, you can imagine doing it. Y squared, 5th power, I'd have 5 of those y squareds written out. Each one of those has 2 y's in it, so we'd have a total of y to the 10th power. Okay, 3 to the 4th power raised to the 7th power, that's way too many 3's. That's going to be 3 to the 28th power. B raised to the 7th power, and then that raised to the 5th power, that will be b raised to the 35th power. Okay, next exponent rule is the product raised to a power property. So this one, we have 2 different bases this time. So if you have a product, AB, raised to the m power, then you can give that power to each of the 2 factors inside a and b. So let's try. Actually, let me show an example that illustrates how it works. If you had xy squared, let's say, this would be the same as xy times xy, because that's what it means to square something. Then multiplication's commutative, right? So you could write that as x times y times y. But then that's x squared y squared. Okay, so let's try it on each of these. We'll have first negative 9 squared times y squared. And we can go ahead and simplify that. That will be 81y squared. Okay, the next one has 3 factors in it, but the behavior is going to be the same. You can picture doing this. If I wrote out 3xy 4 times, we'd have 3 4's, sorry, 4 3's, and then we'd have 4 x's, and then 4 y's. So this will be 81 x to the 4th power, y to the 4th power. Okay, 5wx raised to the 3rd power, that'll be 5 cubed, w cubed, x cubed, 125 w cubed, x cubed. When you raise a product to a power, you can give that exponent to each of the factors inside. Okay. It's important to note that that's for a product. We don't have the same sort of rule about a sum. If you have a plus b raised to the m power, that's not going to be a to the m plus b to the m. Okay, it's not true. Okay, it has to be a product in here. Okay, in the next few examples, we'll see how it looks to use these properties to help us simplify expressions. For an expression to be simplified, it should have no powers raised to powers. It should have as few parentheses as possible, right? So we'll see how this goes. So x cubed raised to the sixth power, that's a power to a power, so we'll multiply exponents. That will give us x18. For the second part, we have x to the fifth raised to the fourth power, multiplying exponents. That gives us x20. Okay, now we have the same base, and so we can add exponents because we're multiplying. This will be x raised to the 38th power. Okay, let's try the next one. For the next one, we have a product, all raised to the second power. We'll give each of the factors inside that exponent of 2. Okay, so now we have a couple of squarings to do. Negative 6 squared would be 36. X to the fourth power squared will be x to the 8th power. Y to the 5th power squared will be y to the 10th power. Okay. Here's a couple of examples where we've used multiple properties to simplify. Okay. Here are a couple more examples to try. Here we have a power raised to a power, a to the fourth power raised to the fifth power, and then that's multiplied by a to the seventh power raised to the fourth power. So take a minute, pause the video, try this one yourself, and restart the video and see how you did. Okay, so for the power to a power part, we will multiply exponents. So that will be a 20th and then a 28th. Since we're multiplying, we'll now add exponents, get a 48. Okay, make sure that you got that, and if not, make sure that you can rework it until you do get it. Okay, W 20th times W9, that will be W 29. Okay. All right, so our next task is to look at multiplying monomials, and we're going to use exponent rules to help us get this done. We have 5x cubed times negative 7x to the fourth power. What we're going to do first is reassociate our multiplications. So let me take the parentheses off of our second group of factors there. We'll write that as 5 times negative 7 x cubed x4. 5 times negative 7 is negative 35. And then x cubed times x to the fourth power is x to the seventh power. Okay, so you saw that we multiplied the coefficients and added the exponents to make that happen. Okay, let's try this next one. Here we have 2/5, a fourth power, b cubed, 15, ab cubed. So as before, I'm going to rewrite this, rearranging the factors so that like bases are together. So this is what we'll have. Okay, 2/5 times 15, a to the fourth power and then a couple of b cubes. Okay, 2/5 of 15 is going to be 6. A to the fourth power times a is a to the fifth power. And then b cubed times b cubed is b to the sixth power. Okay, you'll notice when we're fully simplified, we don't have the same base written more than once. We don't have powers raised to powers anymore, and we don't have any parentheses left. Okay, there's a couple more examples, and then we'll be all finished. So once again, try pausing the video, try this example yourself, and then restart the video and see how you've done. All right, so for this first one, we have 5r squared cubed. This is a product raised to a power, so we'll give the bases inside that exponent of 3. So everything there inside is getting cubed. For now, there's nothing happening to the second part. We'll just leave that as 3r squared. Okay, now 5 cubed is 125. R squared raised to the third power will be r to the sixth power. And then we'll have that multiplied by 3r squared. Okay, rearranging our factors, 3 times 125 will be 375. And then r to the sixth power times r squared is r8. Okay, and that will be that one. Okay, 4ab squared. Let's do this one the long way just for fun. This will be 4ab times 4ab. That is 16a squared b squared. And that's what you get if you squared each of the factors inside. Next, we have m squared n squared. So let me square those things inside. So we'll have m squared squared and then an n squared. In the second part, we have 2m n to the fifth power, and all of that is raised to the fourth power. So we'll give that fourth power to each factor inside. So we'll have 2 to the fourth power, m to the fourth power, n to the fifth power raised to the fourth power. Okay, it's getting better. It may not look like it, but it is. Raise power to a power here. We have m squared squared. That's m to the fourth power. 2 to the fourth power is 16. M4 is still M4. And n to the fifth power raised to the fourth power is n to the 20th power. Okay, so now we have 16. And then m to the fourth power twice. We have 2 of those. That will be m to the 8th power. We're multiplying, so we're adding exponents. And then n squareds times m 20s. That will be n 22s. Okay, once again, no parentheses, each base written only once, and no powers raised to powers. Okay. All right, so let's see. For this next one, we're going to raise a half to the fourth power. So a half raised to the fourth power will be 1/16. X squared raised to the fourth power. Here we're going to multiply exponents, so we'll have x8. Y cubed raised to the fourth power will give us y12. Next, 4 squared, 16. X to the fifth power squared gives x10. Y cubed squared gives y6. Okay, taking a little break. 1/16 times 16, those guys will multiply to equal 1. So those are gone. Okay, so then in x's, we have x to the 8th times x10. That will give us x18. And then in y's, we'll have 12 and 6. That's also 18. That's interesting. Okay, that will do that. Okay, I think this is our last example. It is. Okay, so we'll have -2 a cubed b squared raised to the fourth power. So this will be -2 to the fourth power, a cubed raised to the fourth power, b squared raised to the fourth power. -2 squared is going to be 16. A cubed raised to the fourth power will be a12. B squared raised to the fourth power will be b8. Okay, and that'll do it. Okay, so this takes care of all of the exponent rules for this section. Just to recap, we saw that there were basically 3 that we had. If you have the same base and you're multiplying, then you keep the same base and you add exponents. I may be using different letters this time, but that's okay. X to the a power times x to the b power will be the same as x raised to the a plus b power. We had the power to a power rule, which is x raised to the a raised to the b power is the same as x raised to the ab power. And then finally, we had the product raised to a power. There we give each of the factors inside that exponent. All right, so we've done enough work here that we're going to be able to multiply polynomials, and that's what we'll be taking up in the next section. So in the meantime, let me know if you have any questions, and then have a great day.